Good morning, everybody. Welcome to today's training session. On behalf of SafMed Education, my name is Zana Jardine. I'll be presenting our webinar today. This is the second webinar in our cleaning chemistry series. We'll just be doing two in this particular series. This webinar is brought to you, thankfully, by SafMed, and SafMed has been your solutions partner for the last 30 years. SafMed, of course, is your partner both in the CSSD and the operating room environments. Thank you so much for joining us. For those of you who joined us last week, of course, you'll recall that these are the basics of the topics that we'll be covering today in our two webinar series. The first section we started with last week was cleaning and reminding ourselves what cleaning is about, what it's defined as well as why it is so important to clean our surgical instruments that we're about to use on our patients. We started to learn a little bit more about cleaning chemistries and the terminology that we use when we're talking about cleaning chemistries. So we're a little bit more familiar with all of the terms and the words used. We also covered a little bit on pre-cleaning, the importance of how we transport our instruments, keeping them moist before they get to the main cleaning, and of course the importance of potentially using the correct chemistries, and those kind of chemistries include transport foams and gels. We then went on to talk a little bit about different types of chemistries, and that's where we'll pick up today. We'll start by reminding ourselves about the importance of pre-cleaning, and we'll carry on with cleaning itself, finishing off with chemistries that we use to maintain our instruments and the importance of instrument maintenance. Let's begin by looking at this publication published in the Journal of the AORN, Association of Operating Room Nurses, out of the US. This is part of their 2021 guidelines, and this guideline is referring to, as you can clearly see, instrument cleaning. In the abstract, they go on to remind us that care of surgical instruments and devices is a multifaceted process. And one that I think is very important is that it begins right in the beginning of purchasing and making sure that every facility actually has the resources required to correctly process the devices and instruments that you are about to purchase. Of course, processing encompasses a point of use removal of organic and inorganic materials, then moving on to transport, use of chemicals and equipment to clean and decontaminate, inspection and functioning. Failure to correctly clean and decontaminate can, because we know that dirty instruments can impede subsequent surgical sterilization processes. We know that, and that of course will put our patients at risk. The AORN recommends that perioperative personnel begin preparation for instrument decontamination at the point of use. Every scrub sister or scrub nurse or scrub technician that I know or have personally worked with is really, really good at keeping the instruments clean during the surgical procedure. We know that our instruments won't perform correctly if we don't keep them clean, if we don't get rid of the bits of bone debris, if we don't clean off the blood off the scissors, they won't perform effectively during the surgical procedure. But I'm not 100% sure how good we all are at actually starting that cleaning process, that process just at the end of the case, and making sure that we get everything ready for the next cleaning step. The AORN goes on to say that personnel should saturate instruments with an enzymatic pre-treatment product or place a towel moistened with water on the instruments to keep them moist until such time as the proper cleaning can begin. The guideline says that in addition to facilitating organic debris removal and inhibiting dry surface biofilm formation, enzymatic pre-treatment products can prevent rusting and corrosion. Of course, rusting and corrosion, an important aspect to think about when it comes to maintaining your instruments and keeping that longevity of those very expensive pieces of equipment. Pre-cleaning, an important step in the process. We covered this last week, but we'll recap it again, that surgical instrument detergents, cleaning chemistries are generally divided into a few different principles or four main topics. Number one, enzymatic. Number two, neutral. Number three, alkaline. And the fourth lot we talk about generally will be specialty type chemistries. To remind ourselves detergents that are defined as enzymatic detergents are chemistries that use enzymes that help to create chemical reaction that helps to break down soils into smaller molecules so that those soils can be easily removed and washed away. Enzymatic cleaners or detergents have a neutral pH, and they are highly effective at removing organic soils. Remember that this is important information to think about because we must consider the types of soils our instruments are exposed to. Enzymatic cleaners and detergents are the ones that we use during manual processing, normally at the sink. They can be used in washer disinfectors, but it really depends on how the washer has been set up, its actual wash parameters. Neutral detergents are neither acidic nor alkaline. They are neutral. They offer the broadest material compatibility, which means they are very user-friendly for all types of metals and materials that our instruments are made of. These chemistries often contain specialized surfactants that are going to be important in the removal of soils. They are not that effective when your water conditions are hard. So if you've got hard water that comes out your taps, neutral detergents may not be the right thing for you at your hospital under your circumstances. Then we also divide our the other category, of course, of cleaning chemistries are those that are more alkaline. We start by reminding ourselves of the pH scale. Water is pH has a pH of 7, which is neutral. Something that is more acidic would be something like lemon that's got a pH of 2, stomach acid a pH of 1. Then we go to the other scale, items that are more alkaline. Of course, something like milk is a bit more alkaline. Soap, bleach, drain cleaners, those are really, really highly alkaline materials. Alkaline chemistries can break down a wide range of soils, and they're very effective in the presence of hard water. Because of their high pH, though, we have to use them carefully because of some forms of material compatibility. And they can be a little bit trickier when you are dealing with aluminium type materials, and they generally are only used in an automated washer disinfector process. I spoke a lot about this last week, and this is a webinar that I attended that was hosted by Nancy Kaiser. Nancy Kaiser is a scientist, and she has personally formulated numerous cleaning chemistries and holds numerous patents. So she's the owner of the chemistry formulation, the patents and the numerous that she actually owns. So she's really knowledgeable and very familiar with her topic. And the lecture that I attended and the webinar that I attended, I found incredibly useful. So I'll be referring to a lot of her slides going forward, again in today's, as I did in last week's webinar. One of the important factors or the substrates or components, as we spoke about last week in cleaning chemistries, is in fact surfactants. And don't forget, we spoke about the fact already that all cleaning chemistries contain all sorts of things like water, acids or enzymes, surfactants, chelating agents, corrosion inhibitors, biocides, and solvents. Those are all the components. Surfactants are also known as surface active agents, and their cleaning mechanisms include wetting, emulsifying, and solubilization. Now remember last week we spoke about adding chelating agents into the water or into the detergent, and what chelating agents will do is they'll prevent the minerals that occur naturally in water from remaining or forming white spots on your instruments. Surfactants, on the other hand, are going to also help to prevent organic materials like bloods and fats from redepositing on your instruments. Surfactants will aid in cleaning by wetting, by emulsification, and by solubilization. So what does that all mean? Well, let's have a look at that now over the next few slides. We'll actually get to understand what we mean by that. Surfactants, let's have a look at the image on the left. You can see 3 little red bubbles over there. If you had water that didn't contain surfactant and you put an instrument into that water, you lifted the instrument out, If there were no surfactants in that water, you will just get a bubble or a bead of water. If you add a surfactant, if you look at the image, surfactant A, you're making that bubble less round. It sort of floats out a little bit. If you're adding more surfactants, and we're looking at surfactant B over there, that water spreads more. So what surfactants do is they break the surface tension of water, which means they help for wetting. So if you look at my little bead of water on the plate over there, instead of just getting a bead of water on an instrument, it actually makes the water have better contact with the instrument itself, which then means the detergent is going to have better contact with the soil. It's going to penetrate the soil on your instrument better, as well as it's going to get into all the nooks and crannies of your instrument. So if we add a surfactant to the detergent formulation, it makes water wetter. It makes it better to penetrate the soils. It's going to add value in the cleaning efficacy. So that is wetting. Let's understand emulsification. So emulsification is about getting the soils off the instrument. If the soil remains on the instrument, it's a bit hard to break it down because I can't get to all sides of the soil. So it's very important to try lift the soil up off the instrument itself and put it in the water materials, in the water itself. If you look at my beaker on the right, the image of the two beakers, the beaker on the left, you can see a layer of blue soil at the bottom of the beaker. That's before you add an emulsifier. Once you add the surfactant with emulsification, what happens is that soil is now no longer sitting on the bottom of the beaker. It moves up into little pieces, it breaks up into little pieces, and it's floating in the water. That means that soil is now more readily available for the enzymes to actually break them down. So that's emulsification. Now, what is solubilization? Solubilization is about dissolving the soils. And for the best cleaning results, chemists like Nancy is going to combine a whole lot of different types of surfactants into her detergent chemistry so that the water wets more, so that the detergents help by emulsification, getting the dirt up off the instrument, and so that we can also help dilute or dissolve some of the detergent or the dirt into the water detergent solution. You can see in the image over there where what was a blue line at the bottom of the beaker is now soils that are mixed in the water itself. In the solvent, that's the water, it's now mixed in there. And those are together, all of those things are going to help with cleaning efficacy. Remember, surfactants, as we've spoken about, is just one substrate, one part of our cleaning chemistry. Surfactants help make water wetter. Surfactants help by emulsifying, by solubilizing, and by preventing any of those soils from redepositing on our instruments as you lift the instrument up out the water, out the bowl, out the sink where you've mixed the soap and water. Doesn't help now. We start removing it, and as you take it out, all the soils deposit again back on your instrument. Of course, when we perform surgery, our instruments are exposed to all parts of the body, all sorts of body components, blood, muscles, nerve tissue, brain tissue, urine, glycol, bowel, and potentially feces, for all you know. So Nancy, in her presentation, then went on to describe a hell of a lot about the molecular structure of the different soil types. And I must admit, I struggled a little bit to follow all of this at this point, because what she was trying to describe at the end of the day is what parts of what chemistries break down what molecular structure in the component of proteins, fats, carbohydrates, and inorganic soils. Because these soils, we need to take into consideration what soils our devices are being exposed to, because we have to have the right type of stuff, the right type of chemistry, the right type of formulation to break down those particular soils. And if you think about it, if you're washing your laundry, the Omo, or whatever the correct terminology is for a laundry soap, has particular chemistry and structures in it to deal with the things that your clothes are exposed to. The type of contaminants in your hair that your shampoo needs to break down are going to be different. And all of those, of course, are different to the soils that a surgical instrument is being exposed to. So we use specific chemical formulations depending on the type of soil and the nature of the soil that needs to be broken down. So she went into great detail about fats, about lipids, and about carbohydrates and the various molecular structures and bonds that hold them together. Little bit past my skill level, but I got a little bit of understanding, and that's what I'll go on to describe now. When it comes to proteins, proteinase material, now almost everything in the body contains proteins. Blood, serum, tissue, bone marrow, synovial fluid, all contain proteins. They all need three things to break them down or to clean them off. You need some form of hydrolysis, you need chelation, and you need surfactants. Remember, we spoke about how the surfactants are going to get the soils off. The chelation, we spoke about managing minerals, but it also helps to affect the structure of the protein. And then the hydrolysis, the breaking down of those soils. Now, protein is insoluble. It doesn't dissolve. So that's why we add the enzymes to our detergent to break down those kind of proteins. And it breaks down the bonds in the proteins. Breaking down the bonds in the proteins means we require less mechanical action, meaning we need less rubbing, less scrubbing, which of course will be helpful to protect our instruments. The harder we rub and scrub, the harder the potential, or the greater the potential to damage those instruments. So these enzymes are going to make the scrubbing action, will make it that we don't need to scrub so hard. Enzymes, of course, work better at warmer temperatures, but you have to be careful not to have it at too hot, because then you start to destroy the enzymes. They break down. And if you think about it, proteins, if you have some fried eggs for breakfast, you don't wash the plate immediately. Those fried eggs sit on that plate and it becomes quite hard to get them off. We know that as proteins dry, they are harder to remove. Proteins are not easy to manage. Chelations, apparently, this is what Nancy taught me, help to break down the secondary structures of protein molecules. And as we said, the surfactants will lift off the soils, making them available from all sides to be broken down. When you're using your cleaning chemistries, always remember to read the label and follow the manufacturer's instructions for use. An example of a chemistry here are the actual instructions for use for this particular chemistry. Over here it says dilute 1 to 4 moles of chemistry in warm water. It goes on to explain that the activity increases as the water temperature increases. Clean for a minimum of 1 to 5 minutes. The cleaning time may be longer if the proteinase material is dried on, or if the water temperature is lower. So often we make up our sink of water and we use that sink for a period of time. Remember, it's going to cool off, and the cooler it gets, the less effective the enzymes are going to be at breaking down the proteins. It does go on to explain, do not exceed 55 degrees. I don't think you'll be able to get your hand in a basin of water that is 55 degrees. I keep a thermometer at the office for that very purpose, and I go into the field often and test the water temperature that we're using. Sometimes it's lower than 30 degrees. Tap water, hot water tends to come out at 40, 45, depending obviously, of course, but don't make it too hot. As you can see, it says discard the solutions when they are visibly soiled, else we are not going to have effective cleaning. Right, so that's managing proteins. What about our other substrates? So Nancy went on to describe in more complex detail how we break down fats and how we break down carbohydrates. Fats, of course, as you know, are not water soluble, and you definitely need surfactants for that process. You need surfactants, you need some form of hydrolysis to break down the bonds, and then you need chelation. And chelation increases the fluid permeability on the lipids, makes it easier to actually penetrate those type of soils. You'll see in the image of the jar, the water alone and the water with surfactants. You can see the difference that the surfactant's going to make when you've got fats to manage. Carbohydrates, as we say, are often or mostly water soluble. And again, for them, we need surfactants, and hydrolysis. And for inorganic soils, we often need chelation. It's one of the important aspects around the inorganic soils. And the kind of inorganic soils that your instruments may be exposed to include, let's see, sometimes there might be ringers lactate involved in the procedure, or the muti for bone cement. Sometimes we use antibiotics or some form of chemicals in what we're doing. So it is very possible for our instruments to be exposed to inorganic materials as well. All right, so let's briefly pause and summarize. We've spoken about enzymatic detergents, neutral detergents, alkaline detergents, and specialty detergents. We'll come back to those. We've spoken about mechanism of cleaning that surfactants do, that they help wet, they help emulsify, they help solubilize. And we've spoken about the fact that you get different soil types, proteins, carbohydrates, fats, and non-organic soils. Their molecular structure is different, and the types of compounds we need to deal with them or to manage them when it comes to cleaning is slightly different. And again, remember, Nancy's going to have to come up with a formulation that looks at all of these concepts, that takes all of these factors into account, and she's also got to think about your water quality. This very nice publication published in the Journal of Hospital Infection Control in 2019, titled Complex Design of Surgical Instruments as a Barrier for Cleaning Effectiveness Favoring Biofilm Formation. And biofilms, of course, are a whole nother story, and the infection control experts on this call know a lot more about biofilms than I do, but what we certainly know is that if biofilms form, it becomes really difficult to clean. Not so easy to clean off a series of biofilms. This article extracts that I've put over there first to remind us that inadequately reprocessed surgical instruments may harbor infectious agents, which may then be transferred to a suitable site for replication, meaning our patients could get surgical site infections. And then what I found incredibly interesting was the majority of reusable surgical instruments become contaminated during surgical procedures. Of course they do. And depending on the type and the site of the surgery, the microbial load can reach values of 1,500 colony-forming units per instrument. That sounds like a hell of a lot of microorganisms to me. And that's why we need a really effective chemistry to do the job of helping us start by removing as much bioburden as possible before we move on to the next stage of reprocessing. Nancy then moved along in her presentation, and she spoke about the fact that the formulations of chemistries that we need to clean effectively. We know that, but they also need to be gentle on the instruments that we're cleaning, as well as compatible with the types of materials and metals and polymers that our instruments are made from. It will also be an added benefit then if those cleaning chemistries contain corrosion inhibitors and chelating agents, because those are the type of things that they'll protect our instruments from getting damaged during cleaning. And not only do you want your cleaning chemistry to do that, you want your supplier to be able to prove that that's what the cleaning chemistries can do. Nancy gave an example of what the inside of a washer disinfector could look like if using a chemistry that doesn't contain chelation agents, and one that, again, after using a chemistry that does contain chelation agents, you can see what the difference is in the inside of the chamber of that automated washer disinfector. On the right are some images of some aluminium plates that were soaked in a variety of different components and materials, and you can see the various color changes on them. Let's use an even better example. This is an experiment performed by the manufacturer of a detergent. They mixed a batch of enzymatic detergent and water, and they soaked a pair of scissors in it for 5 weeks. So I left them in the water or in the detergent mix for 5 weeks and then took them out to see what the effect was. The image on the left you can see over there, that's a pair of scissors that spent 5 weeks in just tap water alone. Remember I told you that after, hopefully I mentioned it last week, if you leave an instrument in tap water for just 1 hour, the corrosion process begins. After 5 weeks, it really does eat away at your instrument. And of course, this manufacturer, the whole idea was to add anti-corrosion properties to their detergent so that after 5 weeks of soaking in their particular enzymatic detergent, as you can see on the right over there, the instrument or the pair of scissors has not corroded. Absolutely ideal if your detergent can give you all of these factors. Moving on to another important concept, and I want to talk about rinsing. I was doing a site visit. As you know, I often audit CSSDs and try assist wherever I can in all your practices and in your various designs to help improve your various practices. And in one particular CSSD, I was standing and watching somebody clean some instruments. They cleaned everything and they never rinsed once. So I asked the lady concerned why was it she wasn't rinsing, and her answer was she didn't have time to rinse. And my thought was, I don't have time to come to this hospital then, because I think that's a little risky. Rinsing is a very important part of what we do. This is an article published in a journal called Biomedical Instrumentation and Technology. It's part of the AMI group. Some of you who are aware of the American standards may have heard of AMI before. So in the introduction, it talks to the fact that detergent-based formulations play an important role in the effectiveness of clinical soil removal, that the formulations, often referred to as cleaning chemistries or detergents, consist of various chemicals, including surfactants, designed to loosen and remove various soil types from device surfaces, such proteinaceous material following patient procedures. The use of detergents and associated chemistries is necessary to achieve the cleanability of the reusable instruments during manual and automated processes. The whole aspect of this research was about finding ways to verify the fact that we'd rinsed off the various detergent residuals and the importance thereof. And it goes on to sum up that the importance of performing the rinsing step cannot be sufficiently stressed in terms of facilitating removal of detergent residuals and, of course, any bits or traces of debris that are left over there. Failure to do so can affect subsequent steps and will impact patient safety. So please remember, no matter what chemistry you're using, obviously not if it's an instrument milk, you're following the instructions for use. If it's a detergent, please rinse off carefully. You don't want detergent residuals left inside some poor patient's abdomen. Now, when you first start using an automated washer disinfector, the supplier or the manufacturer is going to suggest or supply or recommend that this washer disinfector performs best with a particular chemistry. And they do that for a very important reason, and that's because the detergent and the cycle parameters and the washer itself are set up all together, and they are validated. So the manufacturer of the machine does a whole series of tests, and those tests are described in the ISO standard 15883. So the procurement officers and all of the throughout South Africa are really good in the tender specs, and they say we want a washer disinfector that is compliant with ISO 15883. So when you're buying that washer that is now compliant, you get chemistries that are validated for that process. If for some reason you now think, okay, I want to change my chemistries because I know I can get another one, you can't just go ahead and do that because your machine is now no longer compliant. You cannot verify that the process is working correctly anymore. There's so many tests that have to be performed by the manufacturer to make sure that it's cleaning effectively. Not only that, they also have to test that the processed chemicals that are used are actually removed properly in the rinsing phase, one of the type tests that they have to do. So the setup of your washer with its chemistries is very important. It's something you can't just change ad hoc, something you have to consult your supplier or manufacturer of the machine before you, or if you decide you want to try change to some other chemistry. It may not actually be possible. Right, so what have we covered? We've spoken about cleaning, we've spoken about cleaning chemistry substrates. We've spoken about the importance of keeping our instruments moist until such time as we can do the main cleaning process, and that enzymatic sprays and gels and foams can be really, really useful for pre-cleaning processes. We've spoken about the fact that we need our scrub staff to please help in the process and start and help facilitate the main cleaning, and main cleaning, of course, being so important, otherwise we are going to have an issue and cause surgical site infections in our patients. We've spoken about the different types of chemistries, we've spoken about the different types of soils. Now, let's talk about the types of chemistries that we can use to help with maintaining our instruments. Why is it so important to maintain those instruments? Well, any one of you who have bought or ordered surgical instruments knows how much it costs to buy those instruments, how much it costs to put together a whole tray of instruments. It can be incredibly expensive, especially for fine neuro instrumentation. They really are not cheap, and we want to do everything in our power to look after them. So this health purchasing news is based in the US, a very interesting magazine, more of a magazine, but very nicely written articles that are well vetted. So in this particular self-study series, they have a whole range of them in the healthcare purchasing news. The focus was on comprehensive preventative maintenance for surgical instruments. And the article goes on to discuss that to keep operating rooms running efficiently, it's important to have a plan for ensuring that all surgical instruments are functioning safely and that all the instruments are effective and they are ready for use in the procedure. A comprehensive preventative maintenance program helps to ensure that instruments are well cared for, are free of bioburden, and are functioning properly. I always advocate for, I know it's very difficult, generally Monday to Friday, a normal day of the week when our theatres are very, very busy, but when our surgeons go on leave, I often advocate that that's an ideal time to ask the scrub sister to get involved, and together you take those instruments out of play and you have a really, really good look at them and you really start to maintain them and manage them. Of course, it might be too late by then because we really should be doing the maintenance more frequently. But a preventative maintenance will avert costly damage and extend the lifespan of hospital instrument inventories. If you don't have time every day of the week, maybe you can allocate some times on the weekends, as well as some form of Friday afternoon, somewhere where there's slightly quieter times. And if your surgeons are on leave, that's the time to tuck in and start cleaning your instruments and doing some more maintenance on them. To get an accurate accounting of costs, hospitals can't just look at the direct cost to repair and maintain your instruments. You actually have to take into account the consequential costs of injuries and what can happen if your instruments are not effectively maintained, because patient safety is a priority and we can't put a cost on that. This is as described in the article. The article goes on to quote some FDA publications and FDA statistics that were quite scary. I was not aware of this, and it made me quite nervous, I must say. There have been as many as 1,500 incidents a year of poor quality surgical instruments causing harm. Sure, that sounds terrible. Nearly 1,000 incidents of retained pieces of broken instruments. Some of which were not retrieved, and of course these instruments can cause local tissue reactions, infections, disability, and even death in a patient. That sounds absolutely terrible. That made me quite nervous. So the first thing I did is I went to this guideline. So I call it the Red Book. A lot of us call it the Red Book all over the world. It is a guideline that's been put together by the, I forget their name now, the Institution of Instruments. I forget their formal terminology, and of course it's all in German as well. It's called Reprocessing of Instruments to Retain Their Value. The latest edition is the edition 11 at the moment. I see they've actually also launched 2 other guidelines, which I will, which I'm hoping to get as well in the near future. In there, they make this following recommendation, and it's a very important point because as you take your instruments out of an automated washer disinfector, remember they are going to be quite warm. I'm going to pause here for a second. Justin?
Hi, Zana. Sorry, we have a question in the chat box concerning the area that you were just looking at. So I wanted to check whether you would want to talk to that now or whether we should look at the questions at the end of the meeting.
Let's look at it now. I haven't seen it. Will you? I'm
Sure.
not on the chat box.
Absolutely. The question is, as for pre-enzymatic agent, what is the impact if it leaves foam in the instrument washer during the washing process?
Okay, again, depending on the setup of your washer disinfector, it might be necessary for you to pre-rinse. So spraying the instruments with enzymatic pre-treatments keeps them moist during the transport phase, starts to loosen the dirt a little bit, makes it a little bit easier. If you find that you're getting a bit of extra foam formation in your washer disinfector, then you can just pre-rinse them quickly before popping them into the washer disinfector. Everything depends on the setup and formulations, how they all work together. Thank you, Justin. All right, back to the red book. An important point as we take our instruments out of the washer disinfector, of course, they are quite warm. Always allow your instruments to cool down to room temperature before opening and closing them. So if you want to inspect them to make sure that they're functioning properly, be cautious about opening them and closing them until, of course, they've cooled down. If you don't, it's possible that the metal parts rub together against each other, and that will cause what is known as fretting. It's in a form of abrasion, and that can impair the instrument's ease of movement or even destroy its functionality. Very important to bear in mind, a point to bear in mind when you take the instruments out the washer. Same applies if you're trying to use them in the operating room and they were so damn hot and you've now got them in the operating room. It's problematic. Remember, we need enough instrumentation that everything can cool down well. So the Red Book goes on to say that maintenance or care is very important, and maintenance and care should include application of instrument milk to the hinges, joints, locks, threads, or friction surfaces of instruments, such as clamp, scissors, or punches, after they have been carefully cleaned and disinfected. This prevents metal-on-metal friction and therefore constitutes a preventative measure against friction corrosion. And this way, instruments are kept functional and hinge action is maintained. Remember, though, when it comes to the correct process and procedure, you will always want to consult the instrument manufacturer's guidelines. So if you have a guideline, whatever instruments you buy, if they are reusable instruments, they have to be sold with a set of instructions for cleaning and maintenance. And those will include a description on whether to use instrument milks or whether to use certain other types of materials for lubrication. You need to follow those instructions, please. That's how you maintain your instruments. Follow the instructions. I'm referring to the general guidelines now proposed in this Red Book. If you're using an instrument milk, as per the instructions for use, make sure, please, that you have a copy of the product's technical data sheet. That technical data sheet will tell you a lot about the product, what the product is designed for, give you a little more detail on the product. Remember, you want something that's got excellent lubricating ability that helps extend the instrument's lifespan and helps to keep it operating smoothly. You want something that does not interfere with steam or EO sterilization. So you can't go buy Q20 or whatever the product's called off the shelf from the garage. You need a medical product, something that is designed for surgical instruments, not to spray your autoclave with. Something nice if your product is then a neutral pH, so it's safe for use on stainless steel and aluminiums. And of course, if you're using those kind of products like milks, they are reusable products because they contain preservatives that will not support the growth of microorganisms when you're using them over an extended period of time, if that's the type of product that you are using. You want to know what substrates the chemistry is compatible with. Can you put, some instruments are made up of more than just stainless steel. If you think of laparoscopic instruments, there are all sorts of components to them. And these days, our instruments are made up of all sorts of things, nylons, neoprene, silicone, polypropylene. So you want to know what the compatibility is. The various stainless steels and the grades of stainless steels that are compatible with that particular instrument milk to maintain the smooth operating of your instruments. The Red Book also then goes on to describe materials used in the manufacture of surgical instruments. Now I'm talking about stainless steels and moving on to talk about passivation layer and corrosion. Generally, for surgical instruments, only stainless steel is used, and can, because it's hardened, it's non-rusting, and generally can meet the tough requirements in terms of elasticity, tenacity, rigidity, blade characteristics, resistance to wear, and maximum corrosion resistance. Maximum corrosion resistance. So stainless steel can corrode depending on how it's used, looked after, or managed, but one hopes that it doesn't. The corrosion resistance of stainless steel primarily depends on the formation, the thickness, and the integrity of the passive layer. The passive layer is very important, and it's something that we want to try and maintain. I have to tell you, I spoke about it last week. Often when I'm doing site visits and audits and I have a look, I take a close look at our instruments, and obviously often you want to put that under a magnified magnifying light. It's quite easy to see it. I can often just see it with my naked eye. Often we have this bit of pitting corrosion or those really bad color changes that we need to look at and try and manage. And I think a large part of that is leaving our instruments lying in bowls of water. I really am not fond of bowls of water. The slushing around of the bowl of water when you transport it from the operating room to the dirty side of the CCD is in itself an issue, and leaving the instruments to lie like that in water is not the best idea. It really isn't. So that's why I tend to be in favor of the products that contain the corrosion inhibitors. They're going to help try keep and maintain our instruments for as long as possible. I told you last week when I first heard about these products, I just thought it was people trying to make money. I honestly did. But once I've started examining them, once I started looking at instruments a lot more closely with my masters, I've come to realize that we actually have to look after them a hell of a lot better than we do. The Red Book recommends that, of course, we are needing to inspect our instruments, and when we're inspecting them, we also look for rust and corrosion. If you do find rust, the treatment recommended is to try remove that rust using acid-based cleaning products. If the damage is still superficial, it should be effective. It's not a given or a guarantee, and it depends on the extent of the damage. If it's not superficial, please, you take that instrument out of play. You send that instrument off away, because A, it can break, B, bits of rust can flake off, and what is C? C is it's dangerous. It really and truly is not ideal. And rust seeds can seed from one instrument to the other. So if you leave a rusted instrument in a tray, it can literally seed from one instrument to the next. So please get it off the tray as soon as possible. You don't want to spend a fortune having to replace all of those instruments, and we want to keep our patients safe. So those type of now acid-based chemistries or cleaning agents that we use, we want to look for something that maintains the passive layer, something that's going to remove hard water scales, that's going to remove rusts and stains, is hopefully phosphate-free, so that it's environmentally friendly, is biodegradable, and at the end of the day, we hope will help with refurbishment and reduce your replacement costs. Again, you want to make sure that your product is compatible with a variety of substrates. In this case, these acid-based detergents, remember we spoke about it earlier, we need to be careful with softer metals. And it may say do not use this on aluminium products. Very important to be aware of what you can and cannot use those products with. Good for your stainless steel, but may not be good for all of your instruments. And you may have aluminium containers, but hopefully you don't have too much aluminium in your instrumentation itself. So us in the CCD, we really need to be aware of a number of things. We need to know the detail of our instruments. And so we want to ask our manufacturers, those that sell us those instruments, to help us, to teach us. They should share with the instructions for you so that we can use the right chemistries to maintain and clean our instruments effectively. Nancy, in summary, said that the soils found in instruments are varied, and each soil provides its own challenges. These soils can be cleaned using a variety of mechanisms and cleaning processes, and they should all be a broad spectrum cleaning process. Prevention is easiest, so you really don't want to do any harm and you want to mitigate the damaging effects of water itself. And always remember products that are environmentally friendly, and of course, patient safety is utmost importance. So thank you very much for joining us in our Cleaning Chemistries webinar series. Hopefully now you remember that cleaning is a very important process. We want to prevent surgical site infections. We want to prevent infections or microorganisms being harbored on our surgical devices. We need to make use of cleaning chemistries that are going to be the right thing, that are going to do the right thing, that are going to keep our instruments moist in the cleaning process, that are going to help break down the right type of soils, they're going to work correctly with our right type of washer, and that we also have the right kind of chemistries available to help maintain our instruments, to manage staining and little bits of rust, as well as lubricate our instruments so that they perform correctly. Thank you so much for joining us. As always, I'll be sending you a link to a recording of today's session, as well as a link to the post-webinar test. If you'd like a certificate of attendance, you need to please complete that webinar test, and then you will receive your certificates. I see a number of people have already completed last week's test. Well done on that. So we'll work on those certificates tomorrow and early next week. Thank you kindly for joining us. I hope you learned something new. I certainly did, putting this all together. Thank you so much. Bye.